Now we're going to take up one more problem on the composite bar. The problem number 49. A compound bar shown in figure consisting of three materials and supports a rigid platform weighing 80 kN. Find the stresses and load in each bar if the platform remains horizontal even after the loading. Also find the shortening in length of each bar. So here he has given the details or the data of the bar 1, bar 2, bar 3. So the bar 1 has got the length as 1000 mm and bar 2 has 1500 mm and bar 3 has 2000 mm. Similarly, the area, the bar 1 has got 600, bar 2 is 800 and bar 3 1000 mm square. And the modulus of elasticity, bar 1 has got 2 into 10 to the power of 5, bar 2 is 1.2 and bar 3 1 into 10 to the power of 5 Newton per mm square. Now this is the condition wherein the bar 1, this is the figure wherein you have bar 1, bar 2, bar 3, wherein the length of bar is given, the area of cross section is given, and also the Young's modulus of the materials are given. So the total load applied is 80 kN, which is compressive. So now for static equilibrium, what is the condition? Total load will be equal to load on bar 1 plus load on bar 2 plus load on bar 3. What is total load, which is P, will be equal to P1 plus P2 plus P3. So what is P? 80 kilonewton. So 80,000 will be equal to sigma 1 into A1 plus sigma 2 into A2 plus sigma 3 into A3. Also we know that as the bars remains horizontal after the compression, that means the area of contact at the top surface of all the three bars will going to have the same rectangular bar. So therefore, you are going to have the compression load which is applied from the top. So delta L1 is, what is the general formula? P into L by E into E. So delta L1 will be equal to P1 into L1 by A1 into E1, that is equal to delta 2, which is equal to P2 into L2 by A2 into E2, that is equal to delta 3, which is equal to P3 into L3 by A3 into E3. Now we know what is P1 A1, which is sigma 1. So sigma 1 into L1 by E1, which is equal to sigma 2 into L2 by E2, and which is equal to sigma 3 into L3 by E3. So sigma 1 into what is L1, which is 1000 by 2 into 10 to the power of 5, which is equal to sigma 2 into 1500 by 1.2 into 10 to the power of 5, which is equal to sigma 3 into 2000 by 1.1 into 10 to the power of 5. Therefore, on simplification, sigma 1 will be equal to 2.5 into sigma 2, and also sigma 1 will be equal to 4 sigma 3. So, and also sigma 2 will be equal to 0.44 sigma 1 and sigma 3 will be equal to 0.25 sigma 1. So substituting these values, 80,000 will be equal to sigma 1 into A1 is 600 plus what is sigma 2? 0.4 into sigma 1 into 800, which is A2, and what is sigma 3? Sigma 3 is 0.5 into sigma 1, which is into 1000. So here, once you get these values, so you know and you calculate that value, sigma 1 will be equal to 68.376 Newton per mm square. Once you get sigma 1, you know sigma 2, and then sigma 3 also you can calculate, which is sigma 2 is 0.4 into sigma 1 and sigma 3 is 0.25 into sigma 1. So for that, stress induced in the bar, sigma 1 will be equal to 68.376 Newton per mm square. Stress induced in the bar 2, which is sigma 2, will be equal to 0.4 into sigma 1. So 0.4 into 68.376, you substitute those values, which is on simplification, you will going to get it as 27.35 Newton per mm square. Similarly, stress induced in the bar 3, which is sigma 3, will be equal to 0.25 into 68.376, which is equal to 17.094 Newton per mm square. So what is the load carried by bar 1, which is P1 will be equal to sigma 1 into A1, that is 68.376 into 600. You substitute these values. Then on simplification, you will going to get it as 41025.6 Newton, which is equal to 41 kilonewton. Similarly, load carried by bar 2, which is P2, which is equal to sigma 2 into A2. You substitute the value of sigma 2, which is 27.35 into the length area of cross section of bar 2 is 800, which is given in the problem. So which will be equal to, on simplification, 21880 Newton, which is equal to 21.9 kilonewton. Similarly, load carried by bar 3, which is P3, which is equal to sigma 3 into A3, which is equal to 17, that is 17.094, that is the stress in bar 3, multiplied by 1000. You substitute these values, which is 17.094 Newton, which is 17.1 kilonewton. As the shortening in the length of the bar, delta L1 will be equal to delta L2 is equal to delta L3. So P1 into L1 by A1 into E1, which is equal to sigma 1 into L1 by E1, which is equal to 68.376 into 1000 divided by 2 into 10 to the power of 5, which will be equal to 0.342 mm. So this is how you will be able to find the solution. Thank you.